Hello, my Math 3 scholars. Today we're going to kind of switch gears a little bit and do some geometry in this unit. So we're going to look at parallelograms. Now, remember that a parallelogram is a quadrilateral with both pairs of opposite sides parallel. Okay, so you have this handout, and if you're on the CAMI document, it's 2 different pages. If you want to print it, you can. You don't have to. But if you print it, you can cut out the sides like I did here, and then you can cut these dotted lines, and you'll be able to open this like I'm going to here. So this is how we're going to be looking at each of these. And each of these theorems that we have on the front, then the examples are underneath will go with the theorems. So I'm going to zoom in now just on one particular side so that you can see closer what I'm doing. Okay. All right. So the first theorem we're going to look at today is if a quadrilateral is a parallelogram, then its opposite sides are congruent. Okay, so that means if we have a parallelogram like this, what this theorem says is that this side is congruent to this side, and this side is congruent to this side. Now, those lines that I'm drawing there is what represents something being congruent. That means the same or equal. Okay, so this word congruent right here, that means equal to each other. All right, that means they're equal. So if I were to tell you that this side was 3, then you could tell me that this side down here is also 3. And if I were to tell you that this side is 5, then you could tell me that this side is also 5. So opposite sides are parallel, and those opposite sides are also going to be congruent. So let's look at an example of how we would do that. All right, example 1 says, find the unknown variables in the parallelograms below. Now notice, my variables that I have here are an x and a y. But we just learned a theorem that said that opposite sides of parallelograms are congruent. They're equal. So to find x, I can set 3x equal to 18. To solve that, we divide by 3, and that gives us x equals 6. So my first answer is x equals 6. Then to solve for y, we set y minus 5 equal to 22. To solve for y, we add 5 to both sides, which gives us y equals 27. So our answer there is y equals 27. Okay, if we look at example B, again, we have a parallelogram, which means the opposite sides are congruent. So if I solve for this one here, 9x plus 1 has to equal the 28. So 9x plus 1 equals 28. Subtract 1 from both sides. That gives me 9x equals 27. Divide by 9 on both sides, and we get x equals 3. That's the first x there. Okay, that was these two sides. Now we're going to set these two sides equal to each other. So 2x minus 5 has to equal 11. Add 5 to both sides. That gives us 2x equals 16. Divide by 2, and we get that x equals 8. So that's our other x there. Okay, so if you have a parallelogram, then the opposite sides are going to be congruent. Okay? All right, now let's switch to this theorem. If you have a quadrilateral that's a parallelogram, then not only do you know its opposite sides are congruent, you can also say that its opposite angles are congruent. Okay? So its opposite angles are congruent. So, for instance, if we had this same parallelogram that I drew over here, what that means is that this angle is congruent to this angle because they are opposite, and this angle is congruent to this angle because they are opposite each other. So this theorem says your sides opposite are congruent, and this theorem says that your opposite angles are also congruent. So let's see an example of what we would do for problems like that. Find the unknown variables in the parallelograms below. So we know that these are parallelograms. Now this 7x minus 1 is this angle right here's measurement, and this 139 is this angle's measurement. So that means they are opposite angles. That means they are congruent or equal to each other. So I can set 7x minus 1 equal to 139. Add 1 to both sides. That gives me 7x equals 140. Divide by 7 on both sides, and we get that x equals 20. So our answer here would be x equals 20. Okay, in this example, again, we have this angle, which is 6x minus 1, and this angle up here, which is 7x minus 10. Those angles are opposite each other, and we just learned that that means they are congruent or they are equal to each other. So we can set 7x minus 10 equal to 6x minus 1. Subtract 6x from both sides. That gives me x minus 10 equals negative 1. Add 10 to both sides, and we get x equals 9. So our answer here is x equals 9. So when you have parallelograms, then you can say that their opposite angles are congruent and their opposite sides are congruent. If you have questions, as always, let me know.